3.1 Relations and Functions. Topic 1 Relation, Domain, and Range. A relation is a set of ordered pairs. Any set of ordered pairs automatically relates the set of the first coordinate to the set of the second coordinates. And these sets have special names. The domain of a relation is the set of all the first coordinate, or the x's, and the range of a relation is the set of all second coordinates, or the y's. For example 1, we want to consider the relation 1, 2, 1, 0, 1, negative 1, and 4, negative 5. Describe the domain and the range. So in this case, the domain is your x values. So our domain are going to be 1 and 4. Those are the only unique values. The ones repeat. So that's our domain. Our domain is 1 and 4. The range are the y values. So we have 2, 0, negative 1, and negative 5. That is our range. For topic 2, functions and the vertical line test. A function is a relation in which every element of the domain is paired with exactly one element of the range. No two ordered pairs can have the same x value. The x's do not repeat. So our first example in topic 2, consider the relation 1, 2, 1, 0, 1, negative 1, and 4, negative 5. Is the relation is a function, and if not identified two ordered pairs is proof. So in this case you can see that it is not a function because we have our x's repeating. We've got this 1 over and over again. So the relation is not a function. And to prove that, we can just pick any of those two that have the ones that are the same. So we have the ordered pair 1, 2, and an ordered pair 1, 0. Since two x's cannot be the same, then no 2 points can be vertical to each other. Therefore, when observing a graph, we can determine if it's a function by using the vertical line test. The vertical line test states that if you can draw a vertical line through more than one point, it is not a function. So for example 2, we want to determine the domain and range in interval notation and use the vertical line test to determine if the graph is a function. So domain here is all values of the x. Since we have our arrows going all the way to the left and all the way to the right, then the domain is going to be negative infinity to positive infinity. Okay, and remember, infinity always gets parentheses, never brackets. The range in this case for this graph is going to be 3, because that's the lowest value for the y, to infinity. Is this a function? Well, if we drew a vertical line through any 2 points or any place on this graph, does it go through 2 points? It does not go through 2 points ever. So yes, it is a function. For example 3, we're going to determine the domain and range in the interval notation and determine if the graph is a function. So in this case, our domain and range, we have a circle here, our domain is going to be from left to right. So in this case, our domain is negative 1 to 5, and it's equal to negative 1 and equal to 5 because those are solid dots. The range is our y values, which is from the bottom to the top. So our range in this case is negative 8 to negative 2. Now, is this a function? No, because I can draw a line and it goes through 2 points. Therefore, this is not a function. For example number 4, again we're asked to determine the domain and range in interval notation and determine if the graph is a function. In this case, our domain, again from left to right, our x values, is equal to negative 10 to 0. And our range, our y values, from bottom to top, is from negative 1 up to 4. Now, is this a function? Yes, because I cannot draw a vertical line that goes through more than one point. Therefore, yes, it is a function. Topic 3. Function notation and function evaluation. When a function is defined with an equation in two variables, one represents the domain, usually x, and one represents the range, usually y. Because functions assign each element of the domain to exactly one element of the range, we can solve the equation for y. This leads to a special notation for functions, called function notation. We solve the equation for y, then replace y with f of x, and read as f of x. So for our first example in topic 3, we want to consider the relation 2x minus 2y equals 5x minus 4y. Rewrite the relation as a function. So let's copy our relation. Our goal here is to solve for y. We want to have y on the left. So I'm going to subtract the 2x from both sides, and that'll leave me with negative 2y is equal to 3x, because 5 minus 2 is 3, minus 4y. Now I'm going to move to the y to the left by adding 4y to both sides. And that leaves me with negative 2 and a positive 4 will give me 2. That's supposed to be a y. 2y is equal to 3x. These cancel out. So now to solve for y, we just divide by 2. We end up with y is equal to 3 halves x, or 3x over 2. We're going to rewrite that as a function. So we write f of x is equal to 3 halves x. For example 2 in topic 3, we're going to consider the relation 4y plus the cube root of x is equal to negative 4x plus x squared. And again, we want to solve for y. So let's rewrite it. 4y plus the cube root of x equals negative 4x plus x squared. So to solve for y, the first thing I'm going to do is I'm going to subtract the cube root of x from both sides. And that will give me 4y is equal to the negative cube root of x plus x squared minus 4x. And then we just divide everything by 4. And it simplifies to y equals, these cancel out, negative cube root of x plus x squared minus 4x, all divided by 4. So that's going to leave us with just a minus x at the end, because negative 4x, this is supposed to be a minus here, that's just going to leave us with x when we divide. But this is going to be all over the negative cube root of x, and the x squared is going to be all over 4. So we're going to put those each over 4. So in function notation, we have f of x is equal to negative cube root of x plus x squared over 4 minus x. Given an equation representing a function y equals f of x, we call the x the independent variable and y the dependent variable. Since the value of y depends on the value of x, we input into the formula of f. For example 3, we want to rewrite the relation as a function of x, then evaluate the function and x equals negative 2. So first we want to set this equal to y, change to f of x, and then substitute in negative 2. So we're going to add 6y to both sides to get the y on the left, which will give us negative 3x squared plus 4y equals negative 6x. And then we're going to add the 3x squared to both sides. We'll be left with negative 4y is equal to 3x squared minus 6x, and then we divide by negative 4. And we'll have y equals, that is not a negative 4, that's a positive 4. Sorry about that. So we're dividing by 4. So we will end up with 3x squared minus 6x divided by 4. Write that as a function, so that's f of x is equal to 3x squared minus 6x all over 4. Now we're going to substitute in x is equal to negative 2. So f of negative 2 is equal to 3 times negative 2 squared minus 6 times negative 2 all divided by 4. So f of negative 2 simplifies to 3. Negative 2 squared is a positive 4 minus 6 times negative 2 gives us plus 12 divided by 4. This simplifies to 12 plus 12 divided by 4, which gives us 24 divided by 4, which divides into 6. So f of negative 2 is equal to 6. For our next example, we're going to do that again. Rewrite the relation as a function of x. So for this last one, when we rewrote it as a function of x, this was our function of x. And then we plugged in the negative 2, we got 6. So we're going to do that again. So we have to solve this for y. So the first thing we're going to do here is we're going to subtract the cube root of x from both sides. And we'll end up with negative 2y is equal to negative cube root of x plus x minus 6 squared. And we're going to divide both sides by negative 2. We'll get y is equal to negative cube root of x plus x minus 6 squared all divided by negative 2. We're going to rewrite that as a function. So we got f of x is equal to negative cube root of x plus x minus 6 squared all divided by negative 2. So that is our function. Now we're going to solve f of negative 8. So we're going to have negative cube root of 8, negative 8, plus negative 8 minus 6 squared divided by negative 2. Well, the cube root of 8 is 2, so the negative cube root of 8, because it's an odd, is a negative 2. So this is going to give us the negative of a negative 2 plus negative 8 minus 6 is negative 14 divided by negative 2. So a negative of a negative 2 is just a 2. Negative 14 squared is going to be 196. We're going to divide that by 2. So 196 plus 2 is 198. Divide that by 2. That's a negative 2 on the bottom. Divide that by negative 2 and we get f of negative 8 equal to negative 99. So we have our function and we have our x equals negative 8. Domain and codomain notation. The notation f, a to b, read f defines from a to b. That should be an arrow there. F from a to b, read f defined from a to b, or f maps a to b, implies that f is a function from the set A to the set B. The symbols indicate the domain of f is the set A, and that the range of f is a subset of the set B. In this context, the set B is often called the codomain of f. While f maps from A to B implies the domain of f is the entire set A, there is no requirement for the range of f to be all of B. If it so happens that the range of f actually is the entire set of B, f is said to be unto B. Topic 4. Any values for the argument of a function that result in division by 0 or an even root of a negative number must be excluded from the domain of that function. We can't divide by 0 and you can't do the square root of any negative numbers. So for example 1 in topic 4, we're going to rewrite the relation as a function, then determine the domain. So the first thing we're going to do here is we're going to solve for y by adding 3x to both sides. We end up with negative 3y is equal to 3x minus 3. And then we're going to divide by negative 3. Every little piece by negative 3. I think it's easier just to do it separate in this case. So we get y is equal to 3 divided by negative 3 is going to give us negative 1x, and then negative 3 divided by negative 3 is plus 1. So our function here, our f of x, is equal to negative 1x plus 1. The implied domain is all real numbers. We use this symbol for all real numbers, or negative infinity to infinity, because there are no divided by 0 or square root of negative. So because no dividing by 0 or square root of negative x. For example 2 under topic 4, we want to rewrite the relation as a function, then determine the implied domain. So I'm going to subtract the square root of 1 minus x from both sides first. This is a y. No, it looks like a 4, but it's supposed to be a y. So we get y is equal to negative 1 minus the square root of 1 minus x. So our function is f of x is equal to negative 1 minus the square root of 1 minus x. The square root, I'm going to type this in because it's easier, is defined as long as 1 minus x is greater than or equal to 0. So for x, the implied domain, we're going to do that over here. 1 minus x has to be greater than or equal to 0. So if we subtract 1 from both sides, we get negative x is greater than or equal to negative 1. Divide by the negative 1. X must be greater than or, nope, we flipped the inequality, don't we? Because we divided by a negative number. So we're going to have to flip that to less than or equal to 1. So our domain is actually going to be negative infinity to 1 with a bracket equals the domain. For example number 3, we're given the function f of x is equal to 2x squared minus 7x plus 5. We're going to determine the difference quotient. So we're going to be using this different quotient formula. You'll have that on the formula sheet. So we're going to use this difference quotient. We're going to plug it all in there. So we're going to replace the x with x plus h in both places. So this is going to be equal to 2x plus h squared minus 7x plus h plus 5 minus, now I'm going to put the second thing in parentheses because we have subtraction, so we're going to distribute the negative. We're just going to copy down the f of x, which is our 2x squared minus 7x plus 5. And this is all over h. So I'm going to multiply x plus h times x plus h. When I do that, we get x squared plus xh plus xh again plus h squared. Whenever you have to put an x plus h in a squared, it's always going to give you this. It's always going to give you x squared plus 2xh plus h squared. You're always going to use that. So that's going to give us 2 times x squared plus 2xh plus h squared. And then we're going to distribute our negative 7 here. So we get negative 7x minus 7h plus 5. And then we're just going to change all these signs. So we get minus 2x squared. This minus is being distributed here. So that's going to be a plus, and that's going to be a minus. So we're going to have plus 7x minus 5. And this is all over h. So now we're going to distribute our 2. So we get 2x squared plus 4xh. We're distributing that 2. Plus 2h squared minus 7x minus 7h plus 5 minus 2x squared plus 7x minus 5 all over h. So we're going to cross out some stuff here that we can get rid of. So we have a 2x squared and we have a minus 2x squared. We have a negative 7x and a plus 7x. We have a negative 5 and a positive 5. So those get canceled out, and what we have left is just the 4xh plus 2h squared minus 7h all over h. And then we're going to reduce the h out. Let's do that in our next slide. So we had the 4xh plus 2h squared minus 7h all over h. So when we reduce the h out of each of these, that's going to give us just 4x. Reduce an h out of here, that's going to give us just plus 2h. One of the h's is gone. Reduce an h out here, we just get the minus 7. That's the solution using the difference quotient. For example number 4, so for example 4, given the function f of x is negative 3x minus 7, we're going to determine the difference quotient. And again, we're going to be using the f of x plus h minus f of x over h. So we're going to do negative 3x plus h minus 7 minus negative 3x minus 7 all over h. So here is my x plus h. It only goes in there. We're going to simplify this. We're going to make this going to be plus, this going to become plus, and this is going to become plus because we're going to distribute the negative. Here we're going to distribute a negative 3. So we get negative 3x minus 3h minus 7 plus 3x plus 7 all over h. So we're going to cancel out here negative 3x plus 3x, negative 7 plus 7. So all we're left with is divided by h. I'm sorry about that. Divided by h, which is going to give us just negative 3. I hope you enjoyed this video on relations and functions.